Hello everyone, we are Group 15 and our project is an autonomous multi-drone system for human detection and obstacle avoidance. Our goal is to show how a small team of drones can safely explore a full football field, avoid obstacles, avoid each other, and automatically find a human target with no pilot input. Traditional drones still rely on manual control or simple waypoint navigation. This becomes a problem in environments that are cluttered, unpredictable, or dynamic, such as a football field with people, cones, poles, and other obstacles. Manual control is slow, risky, and cannot scale to multiple drones. So the question is, how can drones make their own decisions, navigate safely, and detect humans autonomously? Our system integrates LiDAR, a camera module, Raspberry Pi, and Pixhawk into one intelligent, self-contained platform. LiDAR builds real-time 2D and 3D maps of the field. The camera performs human detection, and the Raspberry Pi runs mapping, decision-making, and navigation. Pixhawk then executes the commands to fly the drone smoothly and safely. In a multi-drone setup, each drone shares basic position information over Wi-Fi so they don't collide with each other or duplicate the same search area. Once launched, each drone begins scanning the field using LiDAR. The LiDAR points are processed onboard into an occupancy map that shows open space, obstacles, and forbidden regions. At the same time, the camera identifies humans using a lightweight detection model. Based on this combined perception, the drone chooses its movement using algorithms such as a star for planning safe paths, vector field histogram for avoiding obstacles in real time, PID heading control for stable adjustments, and MAV link commands to control the Pixhawk. As new LiDAR and camera data arrive, the drone continuously updates its map and replans its path, meaning it adapts intelligently to changes in the environment. During testing, the drone demonstrated 87% field coverage across our trials, 88% average human detection confidence, 95% obstacle avoidance success, and consistent performance even with moving volunteers and different obstacle layouts. In multi-drone trials, the drones maintained separation, avoided collisions, and cooperatively scanned the field faster than a single drone could. This proof of concept demonstrates the foundation for real-world autonomous drone operations. With full autonomy, multi-drone coordination, and onboard perception, this system can scale to applications such as search and rescue, perimeter patrol, emergency response, stadium monitoring, and large area inspection. Future improvements include adding reinforcement learning navigation, integrating higher resolution sensors, and supporting larger multi-drone teams. In summary, our project shows that combining LiDAR, onboard computing, and intelligent navigation can enable reliable, safe, and autonomous multi-drone behavior. Thank you for watching.